After the introduction of Lodash in the previous section, we will now write an application. Beyond demonstrating the usage of the Lodash library, we will put the principles of mostly functional programming into practice. We will now develop a fully client-side web application. Therefore, expect no API communication and expect no server-side code. Lodash can equally be used on client-side and on server-side though, so for this reason there is not much difference between client-side and full-stack development using Lodash. The application we will write is a Sudoku app. As you can see on screen, a Sudoku table is a 9x9 table where in each cell the value of a cell can either be empty or a number between 1 and 9. Every row, every column, and the two diagonals have to contain each digit once. Furthermore, the 9 areas bounded by the thick borders also have to contain the 9 distinct digits once. In this application, the user should be able to select a cell and change its value. Whenever the value is invalid, the Sudoku table should be marked as invalid. The value of a cell can be changed to become 1 to 9, or the value can also be cleared. At the bottom of the screen, you can see a timer starting from 0 seconds, measuring how much time it takes us to solve the Sudoku puzzle. We will write the application in 5 steps. In the first video, we will model the Sudoku table, followed by the modeling of the field constraints that will check whether the Sudoku table is valid or invalid. In the third video, we will render the Sudoku table. Then comes event handling, making sure that the user can select cells and change their values by using the keyboard. In the fifth and final video, we will validate the table and test our application. So let's start with the modeling of the Sudoku table. Let's review the requirements for the application once more. We have to implement a 9x9 Sudoku grid with validation. Whenever the table is invalid, the Sudoku table has to be rendered as red with a red background. We should be able to change the value of each and every cell from 1 to 9, and we should also provide the ability to clear the value of a field by pressing space. In addition, we have to implement a timer. We will now use bottom-up design for modeling the table. We will just start with playing around with some functions in the developer tools of a browser. So let's start writing some code. First of all, we should be able to create rows and tables. The createRow function is relatively simple. We will use the _times function, so it creates an array with a constant null 9 times. The _times can either repeat a constant or a function. So let's use _times once more in the create table, where we will repeat the application of the createRow function 9 times as well. In this way, we create a matrix of 9 null arrays. If we console the table the result, you can see the 9x9 null matrix created. So far we can create an empty table quite easily. Let's create our test table and let's also add some test data so that we can render some values. If we console the table the new t constant, you can see that the corresponding values are entered on the top left of the Sudoku table. Now, this is not going to be easy for testing, and for this purpose, I will provide you with a second way of creating a row and creating a table. In the createRow, we will use the _map function, which is very similar to the regular map function, by the way, except that _map accepts the array that we map as the first argument, and the second argument is a function that transforms each value inside the array to a new value. We could have just used the regular map function as well. It is not mandatory to use _map function anymore, but now that we are using Lodash, we're going to put the Lodash map function into practice. _range9 creates an array with 9 values ranging from 0 to 8 with an increment of 1. Let's stop for a moment with this _range9. You can see that with the map and the range, we just create an alternative for a for loop, basically. So even though we are not doing looping in Lodash, with the _.range we can easily create a loop-like structure which looks somewhat functional as well. Oh, and by the way, in the previous description I used underscore, and I will use underscore oftentimes instead of Lodash, but the principles apply for both libraries. We're exploring Lodash now. Lodash has more functions than underscore in general, but I will use the underscore name as synonym sometimes because I'm used to naming the Lodash symbol as underscore. So let's test the createRow2 call. You can see that an array of strings is created with the values 4-0 to 4-8. This will make it very easy to test our application because we will exactly know which cells are placed in our result set. Let's continue with the createTable2 function, which is going to use the createRow2 function as well. The createTable2 function has no arguments, and it maps a range of 9, which is basically executing a loop once more, to the createRow2 function. This is similar to the first createTable function, we're just executing a different function. You can see that the corresponding pairs are printed out in a matrix. The second value in the pair is always the column. The first value is always the row. Let's create our test table T2. We will use it in the future. So once more, T2 is printed on screen with the column row pairs. Now let's move on and let's write a function to select a row from the table. It accepts two arguments, the table and the row, and it just returns a table row. This is straightforward. This is just syntactic sugar so that we think in higher abstraction levels, not just array selections. GetRow_T24, for instance, creates a vector with values where the first value in the pairs is always 4. The second value corresponds to the row number. Now let's write the getColumn function as well with the table column index input values. We have to map the table using a function which selects the corresponding element denoted by column index from each row. We can put getColumn into action as well, and you can see that the corresponding vectors are created. Now that we know how to retrieve rows and columns, it is important to know that we also have to retrieve areas. Now you can see that there are 9 areas in the Sudoku table. Let's denote them by x and y coordinates ranging from 0 to 2 each. You can see the mapping on screen. We will retrieve a function where the input arguments are going to be the table reference and the corresponding x and y values, and we are looking for the retrieval of the 9 values inside an area in a simple one-dimensional array. So for instance, you can see the x equals to y equals 1 area on screen. The columns are denoted by 3x, 3x plus 1 and 3x plus 2, and the rows are denoted by 3y, 3y plus 1, 3y plus 2. This is what we're going to retrieve by using Lodash. Let's console table our test table. You can see it on screen. Now let's create an x equals to y equals 1 variable pair, and let's describe the selected rows in an array of arrays. You can see that the selected rows contain the area that we are looking for, starting with the element 3, 6 on the top left and 5, 8 on the bottom right. So let's print the selected area once more, and our task is going to be to find the proper elements. We're going to use the map function to map each row to its corresponding slice from 3x to 3x plus 2. We got an array of arrays. Now, if you console table the array of arrays, you can see that we just got the right elements, the elements that we're interested in, from 3, 6 to 5, 8. But the problem is that this is an array of arrays and we are looking for a simple one-dimensional array. But no problem, we learned about the flatMap function in the section on functors and monads. We learned there that flatMap flattens the result of the mapping and just returns a one-dimensional array. So by applying flatMap, we got the corresponding elements in a simple one-dimensional array. Let's continue by writing a generic getArea function. As discussed before, the input arguments are table, x and y. We will get the rows in the same way as before by retrieving the rows 3y, 3y plus 1 and 3y plus 2. We will then return a flat map of these rows transformed by the function row fat arrow row.slice 3 times x to 3 times x plus 3. The first value 3 times x is the first value that we are interested in, and the second value 3x plus 3 is the first value we are not interested in from the row. Let's exercise the getArea function. You can see that the corresponding elements are retrieved. We will also test the 1, 0 and the 0, 1 pair, and these values are also working perfectly. Now we have retrieved rows, columns and areas. We just have to solve the retrieval of diagonals. We have two diagonals, the main diagonal and the backward diagonal. The retrieval of the main diagonal is a simple mapping where we just retrieve the nth element from the nth row. That's straightforward. Retrieval of the back diagonal is almost the same as the retrieval of the main diagonal. The only exception is that the return value of the map transformer function is not row index but row 8 minus index. Let's test these two functions. The main diagonal, you can see that the row and column number is the same, and in the back diagonal it starts from 0, 8 to 8, 0. So as a summary, you can see all the functions that we created in this video. First, we figured out how to create rows and tables. Then we wrote a getRow and a getColumn function. GetRow was super easy because we just returned the rowth element of the table, and getColumn was a simple mapping. We had to perform some exercises to compute the getArea function first, and we put the flatMap function of Lodash into practice. We learned that flatMap flattens an array of arrays into a one-dimensional array. We concluded this video with the retrieval of the main diagonal and the backwards diagonal.